Good morning to all of you and good night from Siding Spring. Well, 3 is a lucky number. My goodness, we've had lots of attempts at Saturn and it seemed like the clouds always came in at the last moment. But as you can see, we have a very, very nice view. Hi, Jim. You're wet from San Diego. Wow. Well, it's good to have you all here. It's John Griffin. No, so we have Jim Greif and John Griffins. I apologize. Now I can see it. Jim Greif and John Griffin. Jim, I think you've been here yesterday, and John too. So good to have all of you back. I recognize lots of your names now. And wow, we are finally lucky and we can finally go ahead. What you see on the screen, hi from Scotland, that's very nice. So what you see on the screen there is indeed a live view lit by the moon. And the scope that we're going to use, I'm just going to point an arrow, is this one, right? This one. That's the scope we're going to use. So this is a large, it's a large 20-inch scope, and it is absolutely magnificent. It is a very, very robust science machine where you can do spectroscopy with, you can do planetary, and it's got 2 other imaging systems. So you can do fine color imaging, a lot of science on this machine. When I was in Siding Spring recently, I spent quite a lot of time on it because it's a very, very complex animal, because it has 4 imaging trains, so many different cameras. It is very, very difficult to get everything right, and it has a supercomputer running it, which I'm remotely operating. So anyway, very good. When will you be starting the stream? Can you? It should be starting now. Can you? Is it not? It should have started the stream. It should be running now. I hope you can follow it. I just have to ask the question: am I live or am I? It could also be the lag. I'm just going to take a moment. Am I live? So hi from France, and hi everyone. So you should actually be hearing me loud and clear now. There's a lag of about 1 minute, unfortunately. Yes, live. Okay, got it. We're live. Fine. Okay, so this was just a matter of lag. Very good. So anyway, that's the scope we're going to use. So this is a live view, and you can see, yes, you can hear us loud and clear, Paul. Excellent. Good. Unfortunately, we always have this lag, which is rather irritating. It's running for you. Good. And let's hope, just keep on pouring in messages, because sometimes in a live broadcast, the quality goes down, the stream goes down for all kinds of various reasons, because still the technology I'm using is very complex, running telescopes at the same time. So it says not live for you, starting in 5 minutes. That is weird, Andy. I'm absolutely puzzled. You know what, Andy? Refresh the page. I'm going to write there refresh, because I think that could be it. Just refresh the page and start the page again. It should be live, okay? It should be. Okay. So, let's get going. First of all, here is a view of Saturn, and some of you may have seen this yesterday already. I was in beautiful Siding Spring just a week ago, and it was so magnificent. What they've done there is the biggest scalar display of our own solar system. So as you drive from Siding Spring, and it's on an old supervolcano, a very, very dead supervolcano, millions and millions of years ago it was active. And that's why you have this beautiful view. As you know, Australia is... Yep, the link changed. May be using the wrong link. Okay, hang on 1 second. You may be using the wrong link. Let me see if I can just copy this for you. 1 second. Just want to make sure you get this. 1 second. That should be the correct link, okay? I see that 32 people watching now. You should go to iTelescope page. Yes, that is the other possibility. Um, maybe it has been forgotten to put it up. But anyway, sorry about that. If there's a technical glitch, I apologize. But the link that I put there should be able to get you, to get you live. That's strange. Okay. Well, okay. Well, just let me know if this works now, the link that I just put in. So anyway, there's Saturn. So Saturn is... Hi from France. Okay, very good. Hi, Gerald from France. So anyway, we are very much live today, seeing with Saturn. So I just wanted to say they have this beautiful planetary system that they put up out the solar system as you drive from Siding Spring all the way to Sydney, where Pluto is. And you can pass Saturn somewhere around Coonabarabran, just behind it. And this is just such a magnificent a model that they have. It was also incredible because I did some very, very beautiful DSLR imaging. And by the way, just for those of you who've joined or may not know, season 2 is starting next week, and I will be covering a lot of DSLR techniques too. I'll be rolling out the full plan in the next few days. We will run on subscription now, which is $5 per month. I think that's quite a modest amount still. But we have to sustain ourselves. We are a non-profit organization, but so your support is very, very much appreciated. So the view that you see here is of the Milky Way taken with a 16mm fisheye lens, and you can let me just put the arrow, because it's very nice to have an arrow here. You can see that is where the Southern Cross is, right here, where the head of the emu is. And then as we move upwards, this is always the very, very distinct view of Sagittarius. Sagittarius, you can recognize, it's got sort of these horns sticking out. It's an incredible, like an incredible animal when it rises above the horizon. It's absolutely beautiful. And this is a view as it towards the morning. And the Elon how do you pronounce it? I can't even pronounce this. Observatory in UK watching. Very nice. Beautiful. And this is exactly beautiful. This is something you cannot see from the UK at the moment because you're 50 degrees north. But Saturn at the moment is right here, okay, where I'm putting the arrow. There you can see there is a white spot there, and that's where Saturn is, right in Sagittarius, actually very close to our galactic center, which means that's where the black hole is, okay? So this is an image that I just took recently, and I took back home, and it really depicts the beautiful view of the Milky Way, and typically for the southern sky, Sagittarius is very, very high up. Something you don't see from the north. You'll see Sagittarius more on southern latitudes of 30, just rising above the horizon, but never this high. So really, really beautiful to see. Okay, as we then zoom in, there is Saturn very, very clear. Okay, so this was taken a week ago, this image. So Saturn has moved slightly, only very, very slightly. And in fact, I was going through my images yesterday, and it is interesting. This is a blown up image of April 28th compared, I think, to May 2nd, if I recall correctly, May 2nd. And you can see very clearly, if you look at the background stars, these are the background stars, 1, 2, and 3, okay? This star, and this, they are static. And you can clearly see that Saturn has indeed moved this way, okay? So even this is beautiful to see. So you're actually looking at a planet. Very clear that this is a planet, and this has to be Saturn, okay? Unless this is an asteroid or something else, but of this size, very unlikely, okay? So it's very, very much Saturn that we're looking at here. Very nice. Okay, so let's get going. I'm going to go right back to the live screen, switch off my arrows, And yeah, just keep in your questions and comments rolling so I know you're still alive because sometimes I don't know if the stream drops. But you can see in the upper image, we're using camera 2 here. This is, I'm using the exposure of Saturn about every 0.1 seconds exposure and refreshing at a rate of about 3 seconds. So you can definitely see this is Saturn. So let's have a look first of all at Saturn's moons, okay? Because we can do that. I've got it at the moment in planetary. So one second, I'm just going to stop the, go to high. See if this is going to work. Just have to stop this for a second. Yeah. And go to single image. And let me change the setting here. Because I've gone from planetary view to a different stretch. There we go. There we go. And from Ottawa. Hi Bruce. Hi Walter. Welcome. Saturn off the screen. Saturn off the screen. Where do you say Saturn off the screen? I'm not quite sure. Not sure I follow this. But so you see Saturn is in the center, and you can see Saturn's moons here. Okay. You if you look closely, you will able. Let me just increase the exposure to 1 second, so we get Saturn's moons a little bit better out. A little bit of lag there. Okay, now, well, that's good. That's good. Okay, now you can beautifully see Saturn's moons. And let's find out which moons they are, okay? So, if we look at the image now of Saturn's moons, you can see that this is mirror inverted, and this is calculated at 15:05, so this is exactly 7 minutes ago, universal time. So what I need to do in order to identify the moons is I need to flip this image, which I will do here, so that the views are correct. Let me just do this. No, it's edit. I think it's under edit. I always forget. It's edit. Oops, we lost it here. 1 second. Sometimes there's a lag, so just mirror. I think we have to use the mirror. There we go. That's the mirror view. Now just look at the closest, the closest moon. This is definitely Titan. Okay, this is definitely. Hi again from the BBC. Excellent, Pete. Good to have you again. Well, you saw me live. You saw me live last time, so we're back again. But this time I'm broadcasting around Vancouver, and we're remotely controlling. Hi from Buffalo. Good to have you all. So here are the moons of Saturn, and let's compare it to the sky and telescope quickly. Okay, so I've just. Hi from Essex. Good. More and more coming. That is just great. So you can see we have these are the moons. You have in fact Tethys right very, very close. At 12 o'clock, okay? Then you have the famous moon Enceladus, and we will talk about Enceladus, okay, at about 3 o'clock. And then you have the other moons. The most famous one, of course, is Titan at 6 o'clock, right? And the brightest of them all, okay? And Rhea is the furthest out at the moment. So just try and remember this view. And I'm going to flip back to the other screen. And you can see indeed, this view is live. Okay, there you go. Those are Saturn's moons. All beautiful. And it's very, very nice to watch Saturn's moons because they move incredibly rapidly. Okay, so this has to be constantly updated. So we'll talk a bit about Saturn's moons, but Saturn is supposed to have, and I say supposed to have 62 moons, but it has in fact a lot more moons. If you take all the shepherd moons, the so-called shepherd moons, the shepherd moon, a shepherd moon is a very interesting term. It's a moon that keeps all the keeps all the rings at bay. We call these shepherd moons. There must be many shepherd moons, and there would be probably 100, 150 moons or even more moons. Isn't that incredible? Okay, well, that is so much for Saturn, for this view. And before we start diving into the detail of Saturn, let's jump over to our planetary imaging system. So, what am I going to do now? I'll just put my arrow back and point it at the telescope so you can see this. That is the telescope. So what I'm going to do now is at the back of the telescope, pointing right here, are all the cameras. It's very, very complex. You can see this is a very, very heavy loaded telescope. I'm going to now change the image train, the main image train from one to the other. So I'm going to switch the image train with a mirror, and I'm going to go to our planetary imaging system. Okay, so let me do that. Our planetary imaging system, and the way I'm going to do this is quite interesting. Here you see there's a, oh no, it just left again. 1 second. There we go. It's called the Perseus Commander. You can see I'm at the moment at camera 2. Just if you don't know where I'm looking at or what I'm pointing to. Hallo, sunny Germany, guten Tag. Guten Tag, Dr. Knoop. Very nice to have you here. And sunny Germany, that is good to hear. We have sunny Vancouver for a change. So just look at the Perseus Commander. I'm going to go now to the planetary. So I'm switching over, and you can see the imaging train is automatic. It's a mirror switching over from one system to the next. There we go. Okay, so we've done that. We are no more live here on camera 2, and I'm now going to go onto camera 4, which is this camera. And at the moment we don't see anything, which doesn't mean anything. It just means I have to focus the system. Before I'm doing that, I will just bring up the gain so I can actually see where Saturn is, because this is a very, very fine tuning. We are running at f32. Where is fire capture? 1 second. Here we go. There's fire capture. I'm just going to increase the gain so we can see something, and the gamma. And I can see something. Yes, you can see something vaguely now. It's more or less like a magic show here. And you see a massive ring. So what I'm going to do now is bring the system into focus. Okay. Let's see. Where is my focus? There it is. So I'm going to change this now. So this is called Focus Max. System is responding a little bit slow. I'm trying to. 1 second, I'm trying to get it to react here. Finally, my cursor is where it should be. I have to just be patient, please. It's a little bit slow. Okay, here we go. So I'm going to type in 23, what was it, 540. 23,540, move to. So that's the new focus point, and you're going to see that it's going to get much more. A little bit late in Spain. Hola, well, maybe you've had a good siesta. So we are focusing in now. You can see this massive, this out of focus circle getting into focus. So I've moved over to the planetary system. Planetary imaging system, and you can see it virtually rolling into focus now. And as we roll into focus, I'm going to decrease the gain again, because otherwise it's going to get so bright. And also the gamma value. So yeah, there it is. It's still running in focus. Hi Dan from Wien. Very nice. I hope you have a beautiful day like those in Germany. So we're running. We're now on the planetary system, and we're running. We're putting Saturn into focus at f32. Okay, so you can see it coming into focus now. It takes a bit of time because the focus adjustment is completely different. I'm going to just put down the gain a bit. And magically something is appearing here. that is quite good seeing today. For a live view, this is good because, let me just check my settings here, 23,540. I must just check my notes so I have the correct settings here, 23,540. Yes, that's correct. Okay, very nice. So that is indeed a live view of Saturn. I'll just adjust the gain and the gamma value to get a little bit better contrast. There we go. There we go. So very nice. So if you look carefully, you can actually see the ring structure in live view. Now, if we wanted to really get a sharp image, what I would do, and I will do that too, I'm going to just run a recording of Saturn. As you can see, I'm going to press record. So we are now running, I'm now running a 30-second record of Saturn. I can't do this live, but that helps us later. What I can do is I will take the video and we will stack the video and get a better contrast that way. Hi Mark, you're also there. Good morning, Mark. I can see my friend is there from Snohomish. Very nice to have you. Enjoy the live view of Saturn this morning. We finally, I mean, we not only have sunshine on our Seattle northwest coast, but also in Siding Spring we've got beautiful, absolutely beautiful weather. Very nice to have you, Mark. Mark and I are very good friends, and he's helped me a lot on the audio side, especially on the audio side of broadcasting. Okay. So let's jump. So it's very nice. We can actually make the moons visible here too, and I will do that for a second. If we overexpose, you will be able to see the moons, which it's interesting to see that on the planetary. There you go. There, the moons. This is great, isn't it, Mark? The moons are appearing now. You can see that. So just to remind you where the moons are, I will just put the other from Sky and Telescope. So you can see that Titan is the one that's furthest out. You cannot see it at the moment because, but you can see very clearly. You can see the moon called Tethys, and you can definitely see Enceladus. I always have difficulty to pronounce Enceladus, but it is definitely the most the most talked about and famous moon, and we'll get into Enceladus too. So here are the moons. And then I will go back and to the live view and just adjust the gain again of the camera so that we can enjoy the beautiful rings of Saturn. There we go. That's much better. Put down the gamma value. Just adjust it correctly. Very nice. Good. And you can see how the seeing... Hi, Nick. Welcome to our show. And you can see... there are moments where you can actually see the ring structure incredibly clear, and you can see Cassini's, you can definitely see the Cassini division. Here we go. T14 not available to ordinary for planetary work. No. Christopher, you know, this is a very, very complex system. We are thinking on T17 actually, whether we can implement a planetary system. It's a great question. Is a fuzzy picture? Yes, but the fuzzy picture, John, this is a live view, okay? It is actually a very nice fuzzy picture. You have to imagine Saturn is a tiny dot there. We're using, and then actually the seeing is very good because Saturn is high up. It's about 61 degrees up, high from Serbia, and it may look fuzzy, but this is what we do then to improve it. Is we stack the image, and that's what all the planetary experts do. This is actually a very, very good live view because you can see even a fuzzy image. That is through the atmospheric distortion. But there are ways around it. We integrate the image, and then you can see very, very much clearly the gaseous structure of Saturn. You can already see that it is a very flat planet. It's not round at all. It's very, very, it's more egg-shaped. But you do see the Cassini division very well. Hi from Serbia. So actually the fuzzy image, maybe what you're thinking are the beautiful magazine covers. Well, the magazine covers are typically taken either with a Hubble, where you have no atmospheric distortion, or you integrate over many, many hours or days, and you take the finest and really the finest footage that you have. If you look at the experts like Damien Peach, Damien is an absolute expert at planetary images, but he spends really hours and days looking for the finest footage that he then presents. And then you say, oh my goodness, this is fantastic. But it takes a lot of patience to get there, okay? So nothing wrong with the telescope, nothing wrong with everything. it's just there is an incredible art from getting to this picture. And there we just had one moment, we actually had a very, very fine, we saw the fine division of Cassini, okay? So that's my comment, but it's a great question. Live is always very different. Hi, I'm an amateur astronomer from Calcutta, India. I've seen taken such picture. Very nice. So then Santunu, yes, is that the correct pronunciation? Santunu. That is indeed a very good comment. Well, then you appreciate the difficulty of these live views. Yes. People may be used to picture taken from the Cassini probe. Absolutely. Yes. If you think we're going to fly through the, through the division now, well, then you have to hold your breath for a long time. Okay. Very nice. Okay. Well, let's talk a little bit about Saturn. Saturn is incredible. It's got an equatorial diameter. I'm going to stick to kilometers because we have lots of, so excuse me if I don't present this in miles, but there is a big difference, about 20%, between its polar diameter. I can't quite see the setup detail. Can you quickly say which camera I'm using? Okay, I will. Hang on, I will do that. Let me just get back the live video client here. Good, here we go. So, for those of you who've not seen it, okay, I'm going to put my arrow back in the screen. There. This is the telescope we're using, okay? So this is an RCOS system. I think it's a 20-inch, if I recall correctly. It's a 20-inch. And it's got loaded at the back four imaging trains. 4 imaging trains, okay? Very nice to see. Was the focus set at a predetermined point? Yes. I'll explain to you how it works. So we got 4 imaging trains there, and we're switching with a mirror from one to the other. So the planetary system is running at f32, which is typical for planetary systems, but very difficult to accommodate all this on one. We also have a spectrograph, by the way, a high-resolution spectrograph on there. And maybe we can use that later to look at the spectra of stars in coming sessions. But the way it works is we have an automatic focus, and to focus at long focal lengths is actually very difficult. A lot of you amateurs astronomers will know that. Fine-tuning at a long focal length is very, very difficult to get the focus, because the focus is rather flat. So I actually did this over hours. Also this morning I adjusted the focus again, and I just look, the way I focus is, in this case, is I look very carefully at Saturn's rings and adjust the focus backwards and forwards, which is run by a motor, okay? And then I remember the number, okay? That's a 20-inch, yes it is. I only see a 6-inch, but you know, if you have a refractor, a 6-inch refractor, which you probably do have, you actually get Saturn in incredibly good resolution. Of course, the 20-inch, I mean, the 20-inch is an absolute bucket. It's a monster, okay? And you can see actually how this big telescope, take a look where I'm pointing here with the arrow. You can see how it's actually kept at bay. It's got a massive counterbalance here, a huge counterbalance, okay? Very not easy to keep such a huge telescope very accurately pointing. So that's why I got up very early this morning again to make sure everything's pointed correctly. Okay, I hope that answers your question. So very good. Let's jump back to Saturn then, and let's just get this. Let's see. Yeah, there we are. There's the live view of Saturn again. So Saturn is indeed the flattest planet. The equatorial diameter is about 120,000 kilometers. The polar diameter is about 108,000. So yeah, it varies about 10-15% actually. And there's a question from the UK. When you said you're using a planetary camera, does it mean in comparison to others? Great question. Okay, very, very nice question. Can I leave that question for 1 minute? Because I will, hi, and then I will answer this. It's a great question. So let me just go a little bit into Saturn, and then I'll jump back into the equipment. But just keep in pouring your questions. And I do. Oh, so you have a reflector. That's great. You have an 80 millimeter reflector. That's great. Hi from Cancer. Just pour in your questions. I will start explaining a little bit about Saturn now, the astronomy, and then in 5 to 10 minutes I'll get back to all your questions, and then we'll answer them. Okay? So the mass of Saturn is about 95 Earths. And it's known to have 62 moons, but it has a lot more. The rings are absolutely exceptional. I mean, if you look at the ring structure, I'm just going to put my arrow. You know, if you look at them, sometimes the seeing is very good, and you'll see the Cassini division. But the it actually consists of 30 or more rings, and you may have heard the ring division. They start at D, then you go inwards, then you go outwards. D, B. No, I can't spell. I can't do this correctly. It's D, C, B, A, and then I think come E and F. Really absurd. Okay, so that's the way it is. But the density of Saturn is less than water, which means it floats. If you put Saturn in a massive ocean, it would actually float. I mean, it's a crazy thought. What is also interesting about Saturn is its core is probably metallic hydrogen. So Saturn consists 96% of hydrogen and about 3 to 4% of helium, and its magnetic field is very similar to the magnetic field strength of the Earth, which is surprising, very different to Jupiter that has a massive magnetic field. The polar diameter is only 90% of the equatorial diameter, and due to its low density and fast rotation, which is about 10 hours and 34 minutes, that makes it the second shortest day of any solar system's planet. Okay, and you can see the bands of Saturn do follow the Cassini. NASA has done an incredible job of explaining the Cassini mission, which started in 1997. Cassini has been looking at Saturn for 13 years. Saturn takes 29.7 years to rotate around the sun, and during that it's gone through different seasons, and so the illumination of the rings has been different at different times, and they've learned so much. They've even seen the shadows of the shepherd moons or different moons. Absolutely beautiful, really. So I definitely recommend that. So what is Saturn's rings? What is so incredible about Saturn rings? There's so much to say about it. Saturn rings are made mainly of chunks of ice, and actually also a little bit of, you could call it soot or carbonaceous dust. Interestingly enough, Saturn's rings stretch more or less, if Saturn was at Earth, then it almost stretches till the moon, which is quite a distance. So you have an incredible stretch of Saturn's rings, 100, 200, over 200,000 kilometers. But the thickness is only from a few feet to a few meters, absolutely only 20 meters thick, which makes it an absolutely puzzle and an absolute scientific phenomenon. Because actually Saturn rings are made up of billions of small particles, dust grains, but then again you have huge chunks of ice in there, could be as big as mountains. And that is why it is so. Hi from the Ukraine. Good to have you here. Wherever you're from, Sevastopol, or I've been to the Ukraine, so well, Sevastopol is no longer in Ukraine. I should be politically correct here. But anyway, I've been to Yalta and other places. So, anyway, Saturn's rings are divided to 7 groups. I said it already, starting at D, C, B, A, F, G, and H. And what is interesting is what is keeping this incredible structure. What is the structure? What is responsible for the incredible structure that looks so organized? You have a ring that is so thin, and at the same time it is so incredibly wide, stretching almost from Earth to Moon. How is all that possible? Well, it's only partly understood. They are so-called shepherd moons. Shepherd moons are small moons that are, through tidal forces, through gravitational tidal forces, are keeping the small pieces in place. Okay, how can the ring be only a few meters thick? Isn't it crazy, Wolfgang? That is an absolutely crazy. How is this possible? Well, it is something that I definitely cannot answer just like that, because it is very, very complex. You need to do incredibly complex calculations with the moons, and only some of Saturn rings so far have actually been explained, because Saturn has about 150 moons and very, very small moonlets. So not easy to understand. And there are incredible winds in the upper atmosphere, and you also have, very interesting enough, Saturn's Saturn's rings are rotating incredibly fast. Okay, and everything seems to be in sync with the moons there. But these moons are all frozen worlds except for, and you must have heard this on April 13th. There was incredible news about Enceladus, and Enceladus, sorry, I'm mispronouncing this, Enceladus. I always have difficulties with this word, Enceladus. Enceladus. There were these hydrothermal vents on Enceladus. And what is so interesting about these hydrothermal vents is because, as you know, plants and so on live on photosynthesis. There's such a thing called chemosynthesis deep in our oceans, where you have methane, you have hydrogen, carbon dioxide, and you have a lot of minerals in the water. Those, together with heat, can actually sustain life. So there are bacteria that can actually live from these and use these type of minerals as nutrition and synthesize and actually live on that. That means they basically produce energy. And it was very exciting because hydrogen was discovered very, very clearly through some spectroscopic measurements. They clearly identified hydrogen in the deeper oceans, and that makes it very, very interesting. So so far in Enceladus, there's no evidence of life, but that the environment involves carbon dioxide, hydrogen, and that one can synthesize methane that way through a chemical reduction process is actually very, very promising. So that means that a lot more of the missions in future are going to go towards Saturn, which is exciting. So now I'm going to have a look at your questions. Let's see. So who needs a Cassini probe when we have this? Thank you, Maggie. And Santunu says, and focusing depends on the atmospheric conditions. Very much so. Yes, it does. It does. And I've actually adjusted the focus this morning a bit. So I already said hi to Natalia from Ukraine. Wolfgang says, how can it be only a few meters thick when it contains mountains of sided particles? I cannot answer that question. It is an absolute phenomenon, and you will have to go into incredibly deep, incredible deep celestial mechanics in order to explain this. Okay. Yes, need live autostacking, perhaps 10. Absolutely. We use here Autostakkert and Registacks to do that. And I will do some more recording, by the way. I'm glad you're reminding me. Let me quickly do this. I'm going to jump back to Fire Capture and just continue recording here as we do the live show. But I should actually... wait, I'm going to improve this in a second, because otherwise the stack gets too big. So I'm just going to let it run, and then I'm going to select it. So there are some... Alexei says, no, unfortunately... I'm from Dnipro. Okay, but you know the Crimea Observatory. Very nice. Okay, why haven't the debris in Saturn's rings entered the atmosphere due to the orbital degradation? Very good question, and I think that does happen. But first there are many open questions here, Jackson. How old is this ring? That is another question. Okay, the formation of Saturn's rings is not well understood. It is believed that Saturn's rings could have arisen either from the strong tidal forces of degradations of a moon, or it could have been asteroid particles that came in. But that this incredible, and you would really call it a type of resonance or harmony, is kept this so stable, is not easy to explain. And I certainly don't have any simple explanation for that. It is complex celestial mechanics, absolutely. How old is the ring? It's believed that this ring is not that old, actually, Thomas. Not that old. We may be talking about a few 100,000 to a million years, but again, this is not well known. Is the camera monochromatic? Yes, this camera. Okay, and I was going to explain about the camera. So let's jump back to the planetary camera. This is a ZWO camera. It's a monochromatic camera, and I'm just going to, as we speak now, I'm going to decrease the window size here, because what I'm going to do now is I'm going to do stacking. So I'm going to take a new field of view here. This will save us a lot of data, and I'm going to go and record this now live. So the answer is yes. At the moment I've got the luminance filter on. It's got all kinds of different filters. We've got red, green, blue. We've got a UV filter for Venus, and so on. We've got very different filters in this. So yes, it is a monochromatic one. In order to get a color one, I will have to run the red, green, blue, and luminance at the same time. Okay. And there's a solar sphere. I'm using color ZWO. Do you prefer to shoot more? You know, this is a great question. I also, solar sphere and astro radio, I'm also using a color ZWO for my solar scopes, which, by the way, I will be doing in future. If we have a nice day, I will definitely go out with my solar scope and I will show you the color ZWO. The main advantage, of course, of having the monochromatic, you probably know that, is that by stacking image you will get much better results. But actually, this, for a live view, what we're seeing right now is quite good. And I'm going to continue recording. I'm going to do another recording, and you can always see that I'm recording this live. I'm just saving a lot of data by telling the software I only want this specific field of view. And it is 1.25 inches in diameter. Yes, it is. Yes, it is. That is correct. Yes. So these new ZWO cameras are amazing. This, by the way, is a cooled camera. It's cooled. You can see that it is cooled. We can talk about equipment. Look at the, I don't know if you can make out the, I'm pointing my arrow here. You can see the temperature. It's at 4 degrees Celsius. I nearly said Kelvin. That would have been impossible. Because that's a C, not a K. It's definitely a C. So it's at 4 degrees Celsius. Okay, so that is the equipment. Yes, it's a monochromatic camera. It's one of these modern cameras. A color camera would have also been possible, but in order to do imaging, to do color imaging, we indeed have to do, we have to capture several run through several filters. But I'm going to continue just recording now the luminance, and then we'll run to red, green, and blue too, and maybe I'll be able to do a color here. I've been using near infrared narrowband filter with my monochromatic. Oh, that's interesting. And isn't that interesting? Now, Jim, why would that be more? Because it's a narrow band, you get much sharper views. That's an interesting comment. I don't think we have a narrow band on this, but this is something that gives me some thought. I will take that back. That's great. I'll take that back. I will take that information, and I'm just going to move Saturn a little bit into the center again. There we go. It was very, very delicate. But I'll take that information back and look into that. And Santunu says, yes, ZWO cameras are very good. You have the AS, I think that's the same one that I have. I also have the 120. I have that too, and it's great. It's very, very nice camera. Very nice. So let's just change from luminance now to, let me see. We don't have a narrow band on here. You see, we have methane and so on, but that's an interesting comment. Let's just do the red. So I'm just changing the filter wheel to red now. So I have to just increase the gain a little bit. And Jim, that may be a very good point for getting sharper images. So it doesn't look that sharp, at least in live view, but I'm going to record this now. We'll do the red. In San Diego, it helps with our light pollution. Okay, interesting. Yeah, of course, we don't have any serious light pollution out here. We could virtually say zero. But I'm recording red now, and then we'll switch to green and then blue. And let's see if I can, as homework, if I'll be able to make a decent color image. I can't promise that, but I'll try, okay? Let's see. So that's the red image. And then we'll change to green. Okay, and let me just adjust. The green seems to be a bit more fade, so I'll just adjust the gain a little bit. See if the gamma value comes out a bit sharper here. The green seems to... Okay, I'll record the green now. And then we'll do the 30-second blue, and then I'll do a few more luminance, and then at least we have something. And then let's see what we can do with that. Thomas, an atmospheric dispersion corrector helps to get sharp. Now here we have some real experts. That's good. I have never used an atmospheric dispersion corrector. That's interesting. So is that a mirror that basically that is basically correcting the atmospheric dispersion in real time? Clearly no green men on Saturn. No, Philip, that's true. Okay, and what we had, let's do blue too. Finally the blues. Let me just center it again. Oh, that was the wrong way. And up you go. Put it nice in the center. You can see how incredibly delicate this whole thing is. And let me just record this too. Then we have the blue. That's interesting, Thomas. Atmospheric dispersion corrector. So I don't know. I've seen this. Didn't SBIG come out once with a mirror system that corrects for atmospheric distortion? I've never used it. But of course on big telescopes they have this. I don't know actually how well this works for amateur telescopes, so if you have any comments on that, please throw them in. Natalia, what mystifies me is the hexagon on the Saturn's pole. Are there any explanation for this effect? For the hexagon? I don't know about this, Natalia. I don't know. There you got me stunned. I will look it up, okay? If we're back next Saturday, Natalia, I will look into the hexagon, okay? And message retracted. Okay, okay. Maybe it is something you weren't serious about. So let's get back anyway to the luminance. There we go. Whoops. Yeah, there. Actually, the luminance, you can see the look how beautiful the seeing has become a lot better. For deep sky. I see SBIG's was adaptive optics, not dispersion. I see what you see. Yes, this is for deep skies. Yeah, that was adaptive optics. Yes, you're right. Thomas says, have a look at Gudekunst optical systems. Interesting. I will get tomorrow the system. Then I'll check. Interesting. Well, thank you for all these comments. This is very great input. I'm so glad that you're coming with all these very interesting inputs, because, you know, when we look at the planetary systems at Siding Spring, this may be very good for our next system. So in the meantime, actually the seeing has improved quite a lot, because you can see now the Cassini divisions are coming up better and better. And it is also because in the meantime, look where the telescope is pointing. Can you see the position of the telescope at the moment? That's the... Oh wait, my arrow is completely wrong here. Sorry. The arrow should be right here. If you can see the live view here, you can see that the face, that's the north of the wall. Okay, that's the north wall. So that's the highest point. So we are almost we are almost here at the transit point at the moment, and we can confirm that if we look at the view of the sky. Let me just, where is my view of the sky? Oh, I've got so many windows here. 1 second. Let's see. See if this is going to open it. 1 second. ACP Observatory. Ah, there it is. No, that's not what I'm looking for. I'm looking for the sky. Here we go. There's the sky. Yes, there it is. And if you can see, I'm not going to expand it now, but right here is where our telescope is pointing at the moment, and it's just almost perfectly in at transit point. Okay, and then we have to flip the telescope. Sorry, but what is the light? Oh, what is called? No, the light. The light is the moon. It's all moon. At the moment, the moon is very very high. Okay, if you look where the moon is at the moment on the map. Okay, 1 second. I'm going to point my arrow here, and there you go. That's where the moon is. You see no, the moonlight is no harm whatsoever, but it is something. It is very natural. About the hexagon, it's shown in Cassini's photographs from the North Pole. I put a link, though that's impossible. Just Google Saturn hexagon Cassini. We will do that. Thank you for that information, Piotr. Piotr, that's great. I believe you have a nearly perfect seeing right now. How many pictures per second are you taking? I'm taking, this image is being taken at 30 frames per second, okay? The seeing is indeed very, very good. So I will take exactly that hint, and let me just do this and keep on just capturing the luminance, because the seeing is really exceptional at the moment, okay? So let's continue just taking this. So this is taking 30 frames per second, and yeah, so this is anyway, Santunu, this is moonlight, okay? This is the moonlight. So no harm. We would not illuminate the place. It would be completely dark. But the camera that you're seeing there is incredibly sensitive. So it's a video camera that is showing it. But of course, in moonlight is not that difficult. So let's do again let me cycle through it once more. I'm going to do the red quickly, the green and blue, because I completely agree. Seeing is superb now. So let's do whatever we can in recording. This scope, Wolfgang, this scope is located in Siding Spring. It's about 600 kilometers northwest of Sydney. It is in a place near Coonabarabran. It's in the Warrumbungle. Wait, that's a difficult word. Warrumbungle National Park. I'm just typing this so you can see this. Warrumbungle National Park. That's where it is. A beautiful park. That's also where I spent my time, with lots of kangaroos taking beautiful images of the night. I was all alone there. If you look at some of my Periscope, or even the last, the last episode, you will see the type of environment that I was in. Absolutely magnificent. Really magnificent. So let's just change the filter to green. And let's make lots of use of the good seeing that we have. Which scope number is this? I think this is scope number 23, but it's not for the public. This is privately owned. It is a complex scope that we cannot release to the public because it is unfortunately, it is unfortunately very difficult to maneuver, and we would be running non-stop maintenance. So we have to, this is not for, this is only for the Sky Tours that I'm using this. But we will be looking at possibilities. I can't promise it, but we will be looking at possibilities for getting a planetary system, okay? T17 mainly, possibly, okay? I know there's a lot of demand for planetary. It's so exciting to do. So we'll look into that. And if we get sufficiently good results, then we will do it. But usually planetary cameras, planetary systems are very, very dedicated telescopes with certain setup. If you look at Damien Peach's setup, you'll see that he uses very, very special equipment for planetary systems. So it's not something that is absolutely trivial to do. Okay, so I think, have I recorded blue now? I'm just going to record blue again to make sure I've gone through everything. Nothing is easy, but it can be done. Okay, very good. So I think that is, so we talked about Enceladus, and that is in fact everything I have to say. So we've been on this show for nearly 1 hour. Let's switch back to luminance once more. So you get an incredibly lovely view of Saturn. And then I'll expand it as much as I can. Now we're going to very, very much, this is a very, no, that doesn't look nice because we are, that actually doesn't look very nice because there's a limit in resolution that the ZWO camera is doing here. So it's better to leave it like this actually. It is. But if you have any more questions, let me know. But this concludes our wonderful Sunday. Thank you for joining, my friends, and don't forget to join us for season 2. I'm going to roll out season 2. You have the links for all the past episodes. Look at my notes below the episodes. Very often there are links to images which you can download. That's all for free. Okay, you can download them for free. I think episode 2 for season 2 is going to be very exciting. I'll be looking into DSLR camera equipment. I'll do some image processing live, show you how it's done in Lightroom, some Photoshop, some advanced, lots of advanced stuff. Thank you, everyone. Now the comments are coming in, so obviously the delay is working. The delay is working. So season 2 will be very interesting, and I will, if possible, give you a live view from my Solaroscope 2. So lots to look forward to. I don't know whether I should say this here, but it's too costly for me, for my country, to use iTelescope. Can anything be done about that? Santunu, I don't know if I can answer that, but send an email to support@iTelescope.com. Okay, support@iTelescope.com. Will you post the stacks later? If I can, I will. I will release the stacks, and if you, those are. It depends how large the files are, but maybe I will, if possible, I will give the unprocessed ones, which you can then download, okay? And then you can, for those of you who are good in Registacks, can process them yourselves, okay? Do we get the stacked image? Maybe yes, maybe no. Depends on how skilled I am at this. If I think I'm not sufficiently skilled, I'm going to release the stacks, and some of you can have a go at it too, okay? How's that, right? Okay, thank you, everyone. Wonderful. So let me just see, now I have to jump back to my live view here. Where are we now? 1 second. Yes, so I'm going to stop streaming now, and have a lovely day, and thank you so much for being here.